Our next speaker is Wendy Williams. If you'd like to come up, thanks, Wendy. Wendy, so a change of pace now to something back closer to the ground. Wendy leads the MLA research project boosting natural regeneration of the nitrogen capital in grazing lands with the University of Queensland, Northern Territory, Department of Primary Industries and the Queensland Department of Agriculture and Fisheries, focusing on enhancing biocrusts in northern savanna grazing lands. With 20 years of expertise in Australian biocrust and soil nutrient cycling, she explores the role of fire and grazing management in biocrust growth at Kidman Springs Research Station in the Territory and the Wombiana Research Site near Charters Towers. Her research at Kidman Springs investigates biocrust seasonal nitrogen contribution to pastures under different fire frequencies and timings. And Wendy will share actionable insights from this study today. So please welcome Wendy Williams. Now, just when we've got the boosty, you just have to touch it once, and it's got a bit of a delay on it. So don't touch it again.
Good morning, everyone, and yes, I'll watch the beast. I'm really pleased to be here this morning, and let's see if we can get the beast working. Yes. And we're going to talk about biocrusts, which is very close to my heart and a few other people we know. And so I'm just going to refresh your mind on what biocrusts are for those who may not know yet. And they're really just the scum of the earth. You walk on them, you slip over of them, and I've got lots of bruises from them because I've fallen foul of them at times, so particularly in the wet season. So in the dry season they look like this. They're just a like browny blacky surface on the soil, and they're in between all the grass plants. These photos are just from up on the Gibb River Road. We went up there last week, which was great. And so that's what biocrusts are. But they're called biocrusts because it's short for biological soil crusts. And the biological soil crusts refer to the fact that they're active, living soil crusts. So why we believe they're ecological indicators is because of their role in the landscape. Now, little things sometimes bypass our attention, and we don't realise how important they are until we actually multiply it out in a landscape scale. And this afternoon we have a biocrust session, which I'll promote now, and we are going to talk about scaling up on the little things. So the biocrust community as a whole works together, and they're made up of things like cyanobacteria, which you can see on the right-hand side there, and bacteria, microfungi, mosses, liverworts, lots of little tiny things, a lot of them microscopic, which you can see the bottom photo is a scanning electron microscope photo, which shows you the filaments of the cyanobacteria, and the top photo is a real life size photo just taken with a normal mobile phone camera. They're influenced by climate, they're influenced by land management, they're influenced by a lot of different things. So we did a study a few years ago up North Queensland, and we found out that they fix nitrogen. We knew they fixed nitrogen, but we didn't really know how important it was in northern Australia until we realised that it's something that happens across the wet season, and it happens at different rates, and it happens to peak at the height of the wet season. And if I were to put a rainfall graph on here, you'd see that that was peaking at that time. And what happens overall is they contribute around 5 kilos per hectare in a season. Now, this is obviously dependent on the number of rainfall days because they're only active when it rains. They don't, when it's dry, they're inactive. And across that time period, they are also net uptakers of carbon. So it means that they photosynthesize enough to create more carbon and sequester more carbon than lose it, so through decomposition. So when you look here and see where we calculated in parts per million how much uptake and loss over the course of a season, you can actually understand why we need to rest land during the wet season, because you're getting a big decomposition at first, and then you're getting regrowth. And if you don't give the biocrusts a chance to regrow during the wet season, you're going to be losing the important resources of carbon and nitrogen that they're giving you. We've got a wonderful PhD candidate who's delving into the genes and the gene function of biocrusts. And this gives you a demonstration of how important they are. 57 genes involved in the biocrust to do with nitrogen cycling alone. So this is really critical in terms of productivity of land, because this nitrogen is not permanently held within the biocrust. When it rains, it washes out, and you'll hear a bit more about that this afternoon from Jayden. And it actually washes into the soil in a form available to plants straight away, so they can take it up. So you've got moisture in the ground, so plants are active at that stage, and they'll take up this nitrogen. And they're involved in every aspect of the nitrogen cycle. So this is done by gene function work. So just for those who are interested, it's abundance of genes per million reads, and that's how they've worked out. And you can see the role of the biocrust in that aspect. So at Kidman Springs, where we've done some of the research, I just need to take a little breath. We found the biocrusts were quite resilient to fire. So we did an experiment where we tested how quickly they recover, and within 30 days we had new biocrusts growing after they'd been burnt in the season preceding the wet season. We found that there was more carbon and nitrogen in the surface soils in the early dry season fires, and the functional diversity altered between the wet and the dry season. Now we're looking at that in a more detailed manner at the moment, and those results aren't ready yet, but so far the work that we've done shows there are differences between the wet and the dry season, which makes sense because of course they're active in the wet season, and our previous work had shown that there was more diversity as well. So overall, the impacts of fire and the impacts of grazing obviously have an effect on biocrusts, but they do recover. So I know people were talking about regeneration, making divots in the landscape. Biocrusts are well adapted, particularly in Northern Australia, because they're dominated by cyanobacteria in the biomass side, so in the amount that's there, and that you can see the cyanobacteria, and it grows over the surface and it will grow over divots and so forth, so it will recover in moderate grazing types situations. But it's critical, these decisions that are made by land managers, because if you make the wrong decision and you run stock during the wet season and you destroy that recovering biocrust, it can make a real difference to your nitrogen supply. So I'm suggesting that in the soil area of assessing land condition with ABCD, that biocrusts should be included because they're representative of nutrient cycling, of stability, they prevent erosion, they've got infiltration qualities, so they disperse the water more evenly and slowly, so it doesn't wash the soil away. And we also found that seeds established more in the biocrusts in our Kidman Springs work that we did. And there's functional diversity. So from this point of view, I think that we're missing something in land condition reports, and I would look forward to incorporating biocrust's presence as an indicator, a positive indicator. So in summary, and the reason I'm summarising early, you'll find out in a moment, we have microbial diversity, breeds functional resilience. The loss of 1 centimetre of topsoil actually is the loss of a lot of nutrients, a lot of function, a lot of activity that affects everything else that goes on in the soil. So just think about that for a moment and think how easy it is in a drought or by overgrazing that you can lose that 1 centimetre. It is really critically important. So for that, I'd say that biocrusts are positive indicators of soil and pasture quality. So MLA has funded a video on biocrusts. So I'm about to show that to you. This is the first time it's been released, and so you're a privileged audience. And at the end, I'm going to ask a few reactions to it. It goes for around 9 to 10 minutes, and we shot it at west of Alice Springs, between Old Man Plains and Mount Denison. So please enjoy this video.
You know, when you first see it, you just think it's all sediment from after it's rained, everything that's sat there in a pool and then dried out and just sort of flakes up and turns into a crust, really. When you first find out about it, because you just walk past it every day and just think it's dirt or seeds and that, and you have to find out that it's actually keeping your pastures going and growing the food for the cattle.
Biocrust is a group of microorganisms. Because they group together, you can actually see them on the ground and form a skin on the soil surfaces in between the grass plants. By organisms, I mean bacteria, cyanobacteria, liverworts, mosses, lichens. In a semi-arid area or an arid area, you will find biocrusts inhabiting the soil between the grass plants.
We're about 2,700 square kilometres. Yeah, so we're running about sort of 5,000 head of shorthorn Droughtmaster cross cattle and grass-fed free-range cattle. We live in a sort of semi-arid environment, so a lot of what we do revolves around water, supplying water to the cattle. And the most interesting thing we've learned about biocross so far is probably just the role that it plays in improving soil health and grass health. It's something that you walk over, you don't really pay much attention to, but deep down it's doing a lot of work benefiting not just itself and replicating, but it's actually providing nutrients to the grasses and fixing nitrogen into the soil to feed the microbes underneath as well.
We got involved in the biocrust program through our grazing strategies trial here. Old Man Plains came to us in about 2003. The beauties about Old Man Plains was that it was actually part of one of the first pastoral leases in Central Australia. However, it wasn't in pristine condition. What I was actually noticing over the period of time was a change in the actual soils, the soil crust, the water flow, the erosion on a local scale. And I have actually noticed the formation of biocrusts happening before the other notable parameters were being noticed in land condition improvement. I was actually quite excited because I thought to myself that this is the first time that we'll actually be looking at the soil biology with that goal of improving land condition and grass growth per millimetre of rain.
Biocrusts actually help the soil by fixing nitrogen from the air, taking it into the biocrusts. When it rains, that washes into the soil and the roots of the plants could take it up. Rainfall is very important for biocrusts because when they're dry, they're not active at all. They just shut down, and when they're wet, then they start photosynthesising. They're really a crucial part of the landscape. As a producer, the reason why you want biocrusts is that they provide around a third to a half of the nitrogen in a season that you'll get in your arid grasslands or rangelands. And that nitrogen is fixed like legumes fix it, take it into the cells, is cycled and is there as a compost for the soil. When it rains, it breaks down a little bit before it regrows, and that's why it's so important, because it's such an important part of the nitrogen cycle.
The good thing about what we have noticed with improving land conditioning on ONP is not only the stability of the production, but we're actually getting more grass growth per millimetre of rain. That can be contributed to the biocrusts providing more nitrogen to that landscape.
Well, nitrogen fixation, there are specific genes that we can identify that has the ability to fix nitrogen. As an example, one of these genes that we can find is NIFH. If we find this gene in any of these microorganisms, we know that they have the ability to fix nitrogen. And it is like a glue binding soil particles.
Wet season spelling is incredibly important for a biocrust community because that gives it a time with no disturbance, no cattle trampling, no times when it's not able to grow. Wait that little bit, January, February until it's had a chance to recover, then that's ideal. However, what's even more ideal is if you actually spell over the whole wet season at least every second year, because that way you get a good recovery of the biocrust during that time period. Here we have biocrust in between the grass plants, which is how it naturally occurs when it's not eroded. But you can see leftovers of a hoof print where the biocrust is just growing down and around it, so it can cope with a certain degree of trampling, but not too much.
We can think about biocrust as a natural free fertilizer. So what happened in rangelands, and mostly with cattle grazing, is that the cows are taking resources from the land, but we don't have a way to replenish. Biocrust and microorganisms are helping to replenish these carbon and nitrogen back into the soils, so we can guarantee pasture for the next season.
The tips that we've learnt so far is that protecting the biocrust and improving your soil health is about your numbers, is about knowing what the land capability really is throughout a series of seasons, and being able to match stock numbers to the country sustainably. At the end of the day, it'll provide a premium beef and improved land condition, improved soil health, will lead towards more of a consistent production of quality beef.
What we have found is that different management strategies actually do affect the biocrust. So we've been doing 2 studies, one over at Wombiana Grazing Trial in Queensland and one over at Kidman at the Victoria River Research Station. That's where they use fire and have been using a different fire regime over the last 30 years. So we've been looking at the biocrust in those 2 study sites and found that the different management regimes actually produce different functions in the biocrust. So the biocrust actually acts and behaves, and perhaps it has a different composition, it has a different function in those areas.
The way we have to manage the land out here, because we're so limited rainfall, it's to do with your stocking rates. You've got to manage your stocking rates. Generally, you've got a number that you can carry long term and carry through droughts, so it's about sort of maintaining that and giving pasture the chance to grow and during your good seasons, and some areas like spinifex country and that requires burning, so you've got to sort of manage your fires. And
we've seen a vast improvement in our cattle performance. We've definitely been able to get a high level of production and premium beef production, but we've also been able to maintain that production regardless of season and be able to really take out the effect of climate variability.
what we were hoping to achieve out of gaining knowledge of the biocrust, be able to make the land more profitable while also improving the overall health of the soil and the grasses, improving the land condition while also being able to profit off it. Because there's a fine balance point between the two, but you know, if you can find that right balance, well then it's beneficial for everyone. And the better the pasture going in, the better the product coming out.
Thank you, everyone. So I'd just like a little bit of feedback on this. And can I just have a couple of shows of hands about the length of it? First of all, did you find it too long or about right? So let's say if you are happy with the length of it, you found it informative all the way through, so raise your hands, please. I think that's unanimous. Would you like a short version to be able to show people? Hands? Yep. Okay, we've got that. And the content, was there the right level of content in terms of between the production side and the science side? So first of all, we'll just say, yeah, did you agree that there was the right level, or would, and then we'll have a disagree. So right level of, yep, and disagree? No, couple, yes. And the application of this in the field, do you feel that it will be useful as an extension tool, or if you're a producer, you know, like, was the information useful to you? Show of hands again. Excellent. I think, MLA, you have your answer to those questions quite clearly. But I'm happy to discuss with anyone, you know, like who has comments and ideas on any improvements, because this isn't the final version. Unfortunately, it won't be released today, like for you to take home a copy with you, but it will be released very soon by MLA. So, and in addition, I'd like to thank those who participated in this, especially from Alice Springs, Lakota and Chris, and the Martin brothers, the Mount Denison. It was an incredible story where they'd come from being in poor condition to actually really doing a great job of management and recovering from a severe drought and so on. So I think it's, you know, like, we're really pleased to be able to present this today. So just to finish up, these, Tan Minsway is a PhD candidate who will present this afternoon. He's doing some habitat suitability modelling of biocrusts and using Maxent. These are the records we have so far for Australia. Now, I know that in Western Australia there's a lot more records of presence and absence through landscape function analysis that's been done, and I know there's some more records in NT, but we need to fill those gaps. So if you have that data or information available, can you please speak to myself or Tan at some stage, because we need that in order to complete this map, because it's clear that there's lots of biocrusts in Northern Territory and Western Australia, but we don't have the records of them to put on this, to look at establishing what regions, what soil types, what landscapes, actually biocrush should be found. So with that, I'd like to thank you for listening and any questions.
Thank you, Wendy. We have time for a couple of questions. One down the front here, Rosie. No? Yep. Okay.
Yeah, Barry O'Sullivan from North Queensland. A very good video and very informative. Just one couple of questions I was asking myself while watching it, and you'll have a good answer, and it's maybe something that you might put into the video just to balance people like myself that'll be asking these questions. But seeing that biocrust, the first thing I was thinking, well, water will possibly run reasonably quick over that until it gets into the soaking in stage and stuff like that. And also, could those bare areas possibly be promoted to have legumes for the nitrogen, maybe flowers and some sort of diversity, as opposed to the biocrust doing its job?
Thank you, Barry. The first answer to your question is in the dry season, over the course of the dry season, the biocrusts crack and curl. Sorry, yes, and leave a niche for seeds and plants, and also when they first get wet, and I think we may have cut that out of the video where it shows them expanding and absorbing the water and gradually flattening out. But once they absorb that water and they flatten out, they actually act as distributors of the water into where the grass plants are. So there's generally a really good relationship found in all research that's been done. They do repel water in the wet season, in the dry season, sorry. They become hydrophobic because if they were to take on water in the dry season when there was a few millimetres of out of season rain, they would eventually self-destruct. So they actually have sorted it out where they're hydrophilic in the wet season and hydrophobic in the dry season, which is quite an interesting characteristic. And the second part of your question was, oh yeah, about legumes. So the interesting thing about these organisms is that if there's a nitrogen supply there for them, they will use that rather than fixed nitrogen. So they say, well, we're lazy and we're little organisms, so there's nitrogen there already in the ground, so we'll use that. So they're really occupiers and functional in the nitrogen side of things where there's no or low nitrogen.
Next question. Yep. Thank you.
Thank you, Wendy, for a very, very interesting talk. It was wonderful. Wendy, I'm based down in the south as an extension officer. Is MLA considering a similar type of film clip down south? It'd be fantastic.
South, just define south, please.
Yeah, good question. When that last map you put up,
yes.
I'm southwestern New South Wales, Kina pod shrubland, and I noticed how many sites you had, those red dots, it's down in that area.
Yeah, so David Eldridge, who's here and recently retired, is the guru of southern New South Wales and those areas. So I'll dob him in. You need to talk to him about that. And he's giving a talk later on anyway, so you'll get to know who he is. But check him out because this research at the moment is focused on Northern Australia. The biocrusts in southern New South Wales, northern South Australia, in those areas where it's winter rainfall dominated are quite different from the northern biocrusts, and they're a lot more susceptible to trampling. I'll just add that in as a postscript. But certainly there have been a lot of studies done on them, and they're still important in a lot of those landscapes. So David or myself can talk to you about that more later.
Thanks, Wendy. I'm sorry, we'll have to close off questions there. We are running short of time, but Wendy's around, so please tackle her with your queries and your questions. Will you please thank her again for a very interesting talk?